Write a polynomial with leading coefficient 2 that has zeros of x equals 1, x equals -2, and x equals -3. So they told me my zeros. So from my zeros, I can go ahead and figure out the factors that made up the polynomial. So if I have x equals 1, I can just move everything over to the side where the x is, and that'll tell me my factor. So I can minus 1 from both sides and get that x minus 1 equals 0. And then that would mean that one of my factors would be x minus 1. I can then do the same thing with x equals -2. I'll add 2 to both sides and get that another factor would be x plus 2. Same thing for the very last 0 that they told me about. I'll add 3 to both sides using opposite operation, and I'll get that x plus 3 is a factor. I can't forget that they told me that the leading coefficient has to be a 2. So that means that I'll have to put a 2 out here in the front in order for the leading coefficient to be a 2. So this right here is a polynomial that has zeros at x equals 1, x equals -2, and x equals -3. And with those zeros, it also will have a leading coefficient of 2. So from there, I would have to actually do the math and do the multiplying in order to get what the polynomial is in standard form. I choose to multiply the last two factors together. So when I multiply x plus 2 and x plus 3, these will turn into x squared plus 5x plus 6. I use FOIL, I use box, whatever you do to multiply polynomials. I still have a 2x minus 1 that I'll need to multiply. Because again, I'm just trying to multiply the factors out until I get it in standard form, which basically means no parentheses. All right, so now I'm going to go and I'm going to take these right here and I'm going to multiply them together. It doesn't matter what you choose. If you like, you can take the x minus 1 and multiply it by the x squared plus 5x plus 6. It's your choice. I'm choosing to do these two. And so then I'll have that 2 times x minus 1 will turn into 2x minus 2. And I still have an x squared plus 5x plus 6. I only have one more set of parentheses to multiply together, one more set of polynomials. So I multiply the 2x minus 2 by the x squared plus 5x plus 6. And when you do that, you will get that the polynomial that has a leading coefficient of 2 and zeros of x equals 1, x equals -2, and x equals -3 to be that. So that would be my answer. And again, it doesn't matter the order in which you multiply your polynomials as long as you get rid of all of the parentheses eventually. And again, if you need to know what I did, I use box or FOIL. So I'll show you an example of what I mean with the x plus 2 and the x plus 3. I had x plus 2 times x plus 3. So I did x times x and I got x squared. I did x times 3 and I got plus 3x. And then I multiplied the 2 by the x and got 2x. Multiplied the 2 by the 3 and got 6. I combined these, and that's how I got the x squared plus 5x plus 6 when I multiplied them together. And I did the same thing with the 2x minus 2 and the x squared plus 5x plus 6. I took the 2x, I multiplied it by everything in the next parentheses. I took the negative 2, multiplied it by everything in that parentheses, and then I combined like terms. Write a polynomial having zeros 1 and 2 plus I. They're trying to trick me here because they're telling me that I have zeros of x equals 1 and I have zeros of x equals 2 plus I, but I also have the zero of x equals 2 minus I that they didn't tell me about. Because every time I have an imaginary root, an imaginary zero, imaginary solution, an imaginary x-intercept, I have the conjugate as well. So I have the positive version and the negative version of it. So I really have 3 zeros I have to worry about. So writing the polynomial, it'll be very similar to what we previously did in the example from above. I'm going to take the zeros that they told me about. I'm going to write them as factors. And then I'm going to multiply them out. Here we go. X equals 1. I'm going to minus 1 from both sides. So one factor will be x minus 1. I have x equals 2 plus I. I'm going to minus 2 from both sides. X minus 2 equals I. I'm going to then minus I from both sides because I have to get my equation to equal 0 so I can make it into a factor. So I have x minus 2 minus I equals 0. That'll be one of my factors. Let me go ahead and scoot this down. And I'm going to do my last factor. We'll try to find my last factor, minus 2 from both sides. I'm going to add I. And that'll be my last factor. So now I just have to do the math. Before we got to choose which polynomial we were going to multiply together. You can still choose, but it's best to think that you don't have a choice. Always multiply the conjugates together. Always multiply the factors of the conjugates together. So in this case, I'll have x times x, which is x squared, x times negative 2, negative 2x, x times I, plus xi. I'll then take the negative 2 and multiply it by everything. Negative 2 times x, negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times I, negative 2i. And finally, I have to take the negative I, multiply it by everything. Negative I times x, negative xi, negative I times negative 2, positive 2i, and negative I times I is negative I squared. At this point, you'll combine like terms. So you'll notice the steps are not changing as far as what you have to do. You multiply the polynomials, you combine like terms, and then you take that answer, you multiply it by the other polynomial that you have left. When I'm combining like terms, I have a positive xi minus xi, so that's 0. I have a negative 2i plus 2i, that's 0. I have a negative 2x minus 2x, that turns into a negative 4x. So I have an x squared minus 4x plus 4 minus I squared. I'll have to know that I squared, whenever I see an I squared, it equals negative 1. I have to remember that I squared will always be a negative 1. So right here, instead of I squared, I'm going to write negative 1. And I have minus negative 1, which turns it into a positive 1. So it's really 4 plus 1. So then what I have so far is that my polynomial will be x minus 1 times x squared minus 4x plus 5. Because I had 4 plus 1 here, because those change into positives. So I'm almost done. I have one more polynomial, group of polynomials I need to multiply together. So I'm going to multiply these together. And when I multiply these together, I'm going to do the same. I'm going to take x, multiply by x squared, multiply by negative 4x, multiply by 5. Negative 1 times x squared, negative 1 times negative 4x, negative 1 times 5. And I'll get my answer to be x cubed minus 5x squared plus 9x minus 5. That would be my answer.